an explosion. Okay, so if we can continue, we have hazards and hazardous areas. So hazards can be, number one, urban structure fires. Number two, boiling liquid, expanding vapor explosions. Other explosions, toxic emissions. The use the use of electrical equipment in vicinity of water, and the risk of personal injury from moving or falling parts. The presence of biological hazards. So all these are things that can cause fire or can cause a risk in any work environment. So we have the notes are going on. So I want us to go direct to the basic area classification. So how do I know that this is an hazardous area? How do I classify them? So the area classifications can be set rigidly into any standard. So each installation will be different in some respect, and therefore each site must be examined on its individual merits. So there are three situations that can occur in an operating plant with reference to the hazardous areas. So, number one, a situation where an explosion atmosphere is present always or for a long periods because of the operational requirements, i.e., they are continuous. Now, like for example, before we proceed, somebody give me an example of a situation which has an atmosphere with the presence of a long periods of explosion. It can experience an explosion at any time. It's normally there. Give me an example. Humphrey.
Hello.
Are we together?
Yeah.
Can you give me an example of an area that can easily be explosive, that maybe its operations always has a possibility of explosion?
Okay, areas like Mandera, Garissa.
Why?
Because of the Al-Shabaab attacks.
No, we are not talking of the explosion of the Al-Shabaab. We are talking about the fire. You know, we are doing hazardous areas. Our topic was we are doing hazardous areas that are dangerous in doing electrical installation. So we are talking about, when we talk about electrical installation, hazardous areas is fire. Any risk with electricity is fire. So anything that causes an outbreak of fire, that is another hazardous area. So my question is, name any environment that you think is has an environment or an atmosphere that is easily explosive. A place where you can work in, but it is very explosive and fire can come out at any point. Industry like what? Like which one? Give me an example.
Like a power plant.
Yes, like a power plant. Reason being, there are so many fuels there, isn't it?
Yes.
Yeah.
We have now take an example of a place like Iber Africa where we went. You saw that place had a lot of fuel.
Yeah.
Yes.
Like those people who were using diesel to generate electricity. So in a case of fire breakout, that place is highly explosive. It's highly explosive because it has things that can trigger fire to take place. And then number two, we have a situation where the explosive atmosphere occurs frequently. Explosive atmosphere occurs frequently, or if infrequent, then may persist for a considerable time, e.g. the primary. Now a place like now an industry again that maybe produces chemicals. You can remember there's a time that some vehicle which was carrying chemicals along the Nakuru highway exploded and burned a lot of cars, around 40 cars. Can you remember that case?
Yeah, I remember.
Yeah.
So assume an industry that produces those chemicals. Those chemicals are termed as highly inflammable. So anytime that you ignite or any spark of fire or anything that triggers fire is in the presence, then the fire breaks out. So that is another situation. So another situation is a situation in which explosive atmosphere occurs rarely and normally results from the failure of equipment or procedure e.g. the secondary. Now, these are places where we say normally we do our installation. And if you do a wrong installation, maybe that is a secondary cause because it has happened because of failure to do something. So those are the classifications. Now we go to how the methods or the methodology of classification or the source of release. Now, normally when we are doing electrical installation in hazardous areas, they are normally grouped into zones. So these zones are the ones that normally tell you that I'm going. Whenever you do this special installation, we have zones. We normally have zone A, zone B, and zone C. So we are going to look at them. So hazardous classification. So the above criteria is used to classify the areas under the source of release. That is the methodology of classification. So the zonal classification, we have hazardous places are classified in terms of zones on the basis of the frequency and duration of the occurrence of an explosive in atmosphere. So the higher the number of zonal classification, the smaller the risk of an explosion. So let me take you to the next slide. I hope you guys are writing some notes. Eh?
Yes.
Ama ninawapeleka haraka haraka. Nikiwapeleka haraka mniambie. Sawa. Sasa hapo tumeingia sasa classifications. Nimewambia tuko na different zones. So kuna zone 0, zone 1, zone 2 na kuna zingine other books utapata zikiclassify as zone A, zone B, zone C, but it is the same thing. So let us see what zone 0 said. It is a place which an explosive atmosphere consists of a mixture with air of dangerous substances in the form of gas, vapor, or mist in the presence is present continuously or for long periods or frequently. These are places that have this. Its atmosphere is filled with air of dangerous substance in the form of gas, vapor, or mist. You can give me an example of such a place, or we just read to some zote and then we can now classify, isn't it? We go to zone 1. It is a place in which an explosive atmosphere consisting of a mixture of air of dangerous substance in the form of gas, air, vapor, or mix is likely to occur in normal operation. This one is likely to occur in normal operation. And zone 0, it occurs continuously and persistently. And then zone 2 is a place where an explosive atmosphere consisting of a mixture of air of dangerous substances in form of gas, vapor, or mist is not likely to occur in normal operations, but if it does occur, will persist for short period only. So in this table, we have gases, vapor, and mist zone classification. So dusts. That is another classifications now under dust, because the dusts are also other igniters of this. They are also igniters of fire or explosives. So zone 20, it's a place in which an explosive atmosphere in the form of a cloud or a combustible dust in the air is present continuously or for long periods or frequently. And zone 21, it is a place in which an explosive atmosphere in the form of cloud or combustible dust in the air is likely to occur in normal operation occasionally. You can see these things are like the same, is only that we have the upper one is gas and the lower one is dust. So the dust has 2 added besides the numbers of the first one. And then the zone 22 is a place in which an explosive atmosphere is in the form of cloud, combustion, dust, and gas, and is not likely to occur in normal operation. But if it does occur, then it will persist for a short period only. So design philosophy of equipment and installation. I'll jump that because those are notes you'll read. So equipment definitions. The term equipment as defined. Now, equipment that we are going to use in installation of hazardous areas. We have special in equipment that are used for installation in these areas. You cannot just do a normal installation there. That is why they are called special installation. So the equipments are normally classified into number 1, the maximum that is the spark energy can produce. Number 2 is the maximum surface temperature. So for the equipment to be considered safe for use on a plant, the categories of classifications on the equipment must be the same or better than that required by the plant. So the statement of the categories to be counted on a plant, that is by its owner or the use, provides any potential supplier of the equipment or the contractor with a clear understanding of the limits it must. So anytime before you do any installation, you have to know this kind of equipment I'm using. If in case it can produce a spark, what is the maximum sparking that it can produce, or how can it behave? So nature of the explosiveness, you can see that table. That one you look at it later. I'll give you the notes later. Apparatus grouping is there. Then the surface temperature classification, then ignition temperature, i.e. the temperature at which an ignition could occur, for example, due to hot surface of the apparatus, is dependent on the type of the existing gases or vapor. So this ignition temperature is influenced by several factors and is thus dependent on the stipulated testing. Now, the maximum temperature of an exposed surface of an electrical apparatus must always be lower than the ignition temperature. And that is why we said, before you do any installation in these special installations, you have to test the ignition temperature. You have to know what is the maximum ignition temperature that is there in this area, in this substance, maybe the dust, the gas, or the vapor. So after knowing, that, so you have to know that the electrical apparatus that to be used must always be lower. The temperature of the electrical apparatus must always be lower than the ignition temperature of the dust or that. Now, for example, maybe you're using a tester to do some circuit test in the continuity of the circuit, and maybe the tester has been removed from a hot environment, and the temperature of that tester can ignite, has a temperature that can ignite the environment, maybe the gas and what. So you have to be very careful and test. So that is why we are told that we have to take a lot of precaution in doing the testing. So group number 1, electrical equipment with Mtembei.
Yes, I'm here.
Mtembei,
Yes,
how are you?
fine.
Nasikia ni kama background yako inapiga kelele.
Ndivyo inakuwaga hivyo.
Kuna kuku hapo kando. You can mute
Nini?
your mic so that nikimaliza nikianza kuuliza maswali nitaambia watu wa unmute. You can mute your mics, mtanisikia but
Sawa.
so that tukimaliza kusoma then you can unmute your mics.
Okay.
Kumute mic una click tu hapo chini kwa mic. Good. Now we proceed. Group 2, tumesema group 1 equipment, they are equipments with number 1, with deposits of coal dust on the item equipment that is below that degrees. Now without deposit of coal has to have that degrees. So hizo mtasoma. I want to take you to something. I want to give you something. Now, wiring requirements in hazardous locations. After being able to identify the classes or these areas, we have been able to classify them. So we are going to look at the wiring equipments. Zone 1, Zone 2, that is class A, class 2, class 3. You can tulisema zones can be classified as classes. We can have class A, which is zone 0, class 2, wiring outside the classified areas. There's that. Don't know why my notes are not coming. Okay. Division system. Hizo notes nitawapatia. I'm looking for something so that I can explain. Methods for classification, divisions, and locations. So rigid metal conduit, intermediate metal conduits. So wiring methods permitted for class 1, that is division 1 location, are identified in the section that was there earlier. So, and include the threaded rigid metal. So we normally have the types of materials, the types of conduit that can be used to install for class 1. Now, like for class 1, we use the rigid metal conduit and intermediate metal conduit. When we say the rigid metal conduit, these are metals that are very heavy. They are very heavy, and they are things that they are normally like fireproof, because inside the metal, inside the surface inner diameter of the metals, we normally have some dust powder that cannot burn, that they are resistant to explosions. So when they are coated with that dust, they cannot ignite, they cannot explode. So that is why when you are doing installations in such areas, that is zone class 1, or we said in the other side was zone 0, when you are doing such classifications, then what you do is you use this type of metals, because they are very heavy metals that cannot explode. Okay. So those are the types of metal that we have said. You can see the way this metal is. That is the explosive proof equipment. Are you seeing the type of metal that is used there? The conduit itself. The conduit must be installed wrench tight and have 5 full threads fully engaged. And this type of metal is called the rigid metal conduit and intermediate metal conduit that are used to install installation of these classes. So you can see those pictures and the kind of metals that are there. Even if fire comes or breaks out, it cannot explode to the environment. Or even if the substance carried in these pipes are very explosive, they cannot explode. So they'll save this electrical installation there. You can even see the isolator there and how the metals are being installed. Now look at that. Are you seeing at that installation? Are you looking at that installation now? And these are called they are called the rigid metal conduits that are used. Now look at the motors that are installed there, and even the floor is covered with some sand and fine stones to dissolve any substance or any fluid that might have spilled to the floor, so that it cannot come to the surface to ignite any fire. So all the motors, the machines here are very inflammable, are very explosive, but the connection that has been done here, you can see the motors, you can see the pipes that are used to install the motors. You cannot see any exposed wire, you cannot see any exposed cable to the motor. So this is now the class 1 division, or the class 0. Now look at that. Now we have the mineral insulated cable Type MI. The type MI cable is a fairly unique wiring method. It is a factory assembly of one or more conductors insulated with a highly comprehensive refractory mineral insulated enclosed in a liquid tight and gas tight continuous copper or alloy steel sheath. This type of cable is permitted to be used in class 1 locations where the termination fittings are listed for this location. So they are called the mineral insulated. The mineral insulated, these are pipes, metallic pipes that are coated. They're just normal pipes, but they are coated with minerals. So these minerals appear like isolators or insulators that cannot allow fire or explosions to take place. Now we have another one which is called the metal clad cable type MCHL. So in your examinations, you can be told to name some of the materials that can be used in hazardous areas. So these are the materials that you name. Like for example, we talked about the MI. We have also talked about the metal clad and so many others that we'll talk about. You have to know these materials very well and know where they can. Like now, for example, this cable, this type of cable is permitted in cable tray. We can now install this in cable tray in direct sunlight and or indirect barrel or concrete encasement. So the insulation of MCHL, we said it is the metal clad cable, is limited by the code to the industrial establishment. Now look at the way it is installed. Look at the way that cable, that coating is. So this MCHL cable is suitable for classes 1 and 2 division. Now it has even gone to class 2 division. And the class 1 location in industrial establishment with restricted public access, courtesy of the manufacturer, who is called the Thomas Bells. So you can see how it is. The cable itself is like, it appears like it is blue in color, but all that is mineral coating. It is a mineral that has been sprayed on it to coat it and to avoid any explosiveness of that substance.
Some about hazard areas.
Mm-hmm.
Those are areas with dangerous taking place.
Uh-huh.
Then what hazards can be?
Mm-hmm.
Are the urban structures boiling liquid explosion, toxic emission,
Mm-hmm.
biological hazards?
Okay. Good. Hapo kwa ni nani hiyo spika yake inasumbuka nini?
Mtembei.
Mtembei, mwambie aweke hiyo.
Tembei weka hiyo.
Good. Salad,
Yes.
tell us something.
Okay. We learn about how the gas, vapor, is classified. We have zone 0, zone 1, and zone 2.
Mm-hmm.
Zone 0 is a place in which explosive atmosphere consists of a mixture of air, of a dangerous substance, where it take long period or frequently.
Yes.
That's zone 0. And zone 1 is a place whereby explosive atmosphere consists of a mixture of with air of dangerous substance in form of gas.
Mm-hmm.
And it happens no operation.
Uh-huh.
And zone 2 is whereby explosive atmosphere consists of a mixture with the air of a dangerous substance in form of a gas, vapor, and it take a short period of time.
Yeah.
Yes.
So that is a good trial. At least people have understood what we learned. So the most important thing there in the first session of the lesson is for a student to identify the zones. You should know these classifications of zones and what hazardous areas are. And we say that hazardous areas, these are areas that are highly flammable. When I say highly flammable, meaning there is a substance in that area that can explode at any time, that is highly explosive. If it is highly explosive, meaning it can cause fire. It can cause a fire outbreak at any time. We normally see fires breaking out, but have you ever seen a petrol station breaking out of fire? Who has ever seen a fire break out in a petrol station? Amos? Amos?
Yes, madam.
A fire breakout in a petrol station. Have you ever seen that? Yeah?
I've not seen it anywhere.
You've not seen it because those people are very cautious and they have put all the measures and all the precautions necessary to prevent fire breakout, because those places are very flammable, because they have substances that are very flammable. So I'm happy people have gotten something from the first session. So I want us to go to the next session in the next like 30 minutes so that we can go through this. These are some of them will be a repetition of what we have done, but they are going to be an addition of new things in this slide. So the general principles, basic of hazard area classification. We have said we have the fire triangle. The fire triangle is there has to be oxygen, there has to be oxygen, there has to be a combustion, that is fuel and oxygen and air. Fuel, oxygen, and the substance. So all this must be there. So the triangle is used as a method to assist better understanding of the continuous required to create an ignition or an explosion. There must be fuel, that is the flammable substance, that is can be gas or vapor or combustible dust. We have already talked about the dust and the vapor and the gas, that is which are the ignitable quantities. There must be ignition source of energy in form of heat, that is, it can be sparks. And there must be oxygen, usually the oxygen in the air, approximately 21% volume. We normally know that for the oxygen that is normally present here is normally for 21%. So the presence of oxygen promotes fire. So there has to be this oxygen present. Protective equipments, techniques to prevent combustion. We have to remove any one of the elements. So if we remove any of these elements from the environment, then we are going to prevent the explosion from taking place. And then or allow the three elements to coexist and ensure that the energy of the source of the ignition maintained below the specific value. They can exist all the three of them at the same time, but they keep distance. And we said about the distancing. You keep distance, you put a barrier between what can cause a spark and the fuel and the air. So allow the explosion to take place and contain it within the robust exposure. So classifications of hazardous areas hizo tulishasema. We have an area in which an explosion gas or this, and an hazardous areas, these are areas in which an explosion gas atmosphere is not expected at all times. So we have classification divisions or zone system. We have already talked about that. So the standards, that one is not important for us. The divisions we had already talked, class 1, class 2, can be a class or division depending on what. So there are the zones there. We talked about the gaseous, that is zone. The ignitable, those ones we had already talked about them. Divisions, areas, now different zone divisions. We can have division 1, which is zone 1, division 2, which is zone 2, and then non-hazardous is there. General principles basic on the hazardous area classification. Now, when we have a place like this, we want to classify the zones and where is the places that are more dangerous. Now, like for example, the one colored in red is division 1, and we said division 1 is the most is very dangerous area, and then division 2 is the yellow, meaning it's not that explosive as division 1. We go now to the hazardous area still classification, the liquid surfaces and the zones. They're classified using the colors. You can look at the colors. That is still the same. Still under classification. Now, system. We need to know how to manage our system so that it cannot be explosive or cause dangerous. So we have the electro-integration. This is for management to prevent fires from outbreak. So we have to do this monitoring each and every time and scheduling. We monitor and say if this place is supposed to be maintained at this time, we need to maintain it so that we keep off the fire breakouts from our installations. Implementation of that, I want us to go now direct to the installation. I'll give you those notes, so I want to go straight to something so that I explain. Now, preparation of hazardous source list. Types of hazardous area classification, that one we have talked about, and the map. This slide is not moving very fast, but I'm getting something. Now, typical hazardous area classification. You can see this. You can even be told in an examination that using a diagram or using illustration, describe or give differentiate between hazardous areas and non-hazardous areas. You can see the way this person has manually done it. Now the gas lighter than hydrogen, actually ventilated compressor sheet. So the person is just trying to explain using typical and simple drawings to show the differentiation between an area that is hazardous and another one that is not that hazardous. Class 1, we said it is gas and vapor, that which is the class 1 and 2 division that exists during normal operation. This one we have always said. Now, I wanted us to reach at the insulation part. Yes, we are now. Insulation. The cable glands are used when terminating the cable into electrical equipment. They must be selected according to the method of explosion, protection, and environmental conditions. So the requirements cable glands include to firmly secure the cable entering the equipment, to maintain the ingress protection of the equipment, to maintain the earth continuity between the equipment and the cable armoring, to provide the seal onto the inner and outer sheets of the cable, to ensure the containment of the internal explosion in flammable-proof equipment, to prevent gas passing from the flame-proof closure back to the cable, and to maintain an integrity-restricted breathing equipment. You can see those guys working on the equipment. Now, the selection of the cables. This is how we select the cables. You can see even the classifications, the layers of protections that are there. You can see how many layers we have. We have like from D to B to F. You can see all those distances, the armoring that is there. The correct selection of the cable gland is very important. That is the factors considered include number one, the type of cable, number two, the type of X protection, the IP rating of the enclosure into which the gland is fitted, earth continuity and support of cable entering the equipment, and the environment. The insulation now is there. These are the ratings that are put there to show the type of cable. The light rigid conduit insulation class 1 division. You can see that the lighting rigid conduit. Now you can see how to do an installation of the lighting system in such dangerous areas. You can see the pipes, the conduits that are there. You can see that. Inspection and maintenance. We have the introduction, that is the inspection and maintenance should be carried out of the regular basis to enable detection of potential faults early enough to prevent major breakdown to occur. Meaning, when we are doing now, you've already done the installation, so you have to do inspection and maintenance. Inspection and maintenance is meant to avoid any accident to occur. Now, like a maintenance program based on the result of the specific survey can then be implemented, and then the equipment will only remain approved, certified, and maintained according to the recommended way. So we have the inspection and maintenance is still there. We have the safe isolation. Before any inspection, maintenance, or other work that involve opening equipment in the operating plant located as hazardous, permit work must be employed and the plant certified to gas-free. Then you will read all those notes under self-isolation. Qualification of personnel. The person to do this work, who is the person who can do this work? The person who involved in the inspection and maintenance and inclusive shall possess to the extent necessary to perform their task as follows: an understanding of the general principle of the explosion protection, an understanding of the general principles of various explosion. So these are the qualities of somebody who can do the inspection and maintenance. That is the personnel. Now, a person like you, if you are employed in a company, and then you're told that now you are going to do the maintenance of the installation of the electro installation in the industry. So you have to have all the qualities that are listed here for you to be able to perform. You need to have the knowledge and the skill at the same time. So I think we are done. So turn on your mics again. Turn on your mics. Okay, today's presentation will end there, and I would like to hear your views